In this video, we're going to cover naming of nitroalkanes, alkyl halides, and ethers. When you have an NO2 group as a substituent, you can simply just refer to that as nitro. In this example here, our parent chain is shown here in pink. It is 1, 2, 3, 4, 5, 6, 7 carbons long, which gives us a root name of heptane. We also have 2 methyl groups, which is where we get the dimethyl from, and we have a nitro group. We number from the left 1, 2 to put the first substituent at position 2. If we were to number from the right 1, 2, 3, we wouldn't get a substituent until number 3. So that means that we have our methyl groups at positions 2 and 4, and our nitro group at position 5. In this example here, our parent chain is the cyclopentane, and we have 2 nitro groups, 1, 2, so that gives us a 1, 2 dinitro. Again, we're numbering on the ring to give lowest possible numbers. For our alkyl halides, we're going to have fluorine, which becomes fluoro, chlorine, which becomes chloro, bromine, which is bromo, and iodine, which is iodo. So in our first example here, we have a cyclohexane as our parent chain. Our substituents are the bromo group over here. We also have a methyl and an ethyl. We want to number to give lowest possible numbers, but it doesn't really matter where we start in this case. If we start at the bromine, we will have substituents on 1, 3, and 5. And if we start on the methyl group, we have substituents at 1, 3, and 5. So we're going to use alphabetical order to break the tie. That means that the bromo will get the 1, and the ethyl group will get the 3. And that's just due to alphabetical ordering. So we have 1 bromo, 3 ethyl, 5 methyl, cyclohexane. In our second example here, our parent chain is butane, 4 carbons long. We're going to number from the left because we have 3 substituents at this position. If we number from the right, 1, 2, 3, we won't get a substituent until number 3. So we have a cyclopropyl group here, 2 iodo groups here, and a bromo right here. And numbering from the left, that gives us 2 bromo, because B comes first alphabetically, then the 1 cyclopropyl, because C for cyclopropyl comes next alphabetically, and the 2 iodo groups become 1, 1 diiodo. That's because they're both on carbon 1. With ethers, we have a little bit of a challenge because you can have carbon groups on either side of the oxygen. What you end up doing is finding the parent chain, and that gives us the root name, and then the other part of the ether is referred to as an alkoxy substituent. In this example here, we have 8 carbons, and that becomes our parent chain with the root name of octane. At position 3 here, we have our substituent. Because there are 2 carbons attached to the oxygen, this becomes an ethoxy group. We number from the right to give the ethoxy group the lowest possible number, so we get 1, 2, 3 ethoxy. These are some common ether substituents that you'll see. 1 carbon here is methoxy, 2 carbons is ethoxy. Isopropoxy is an isopropyl group. You can compare this to propoxy, which would just have 3 carbons in a row here. And tert butoxy would have a T-butyl group. A regular butoxy would look like this. Here are some more examples of ethers. In this case, the parent chain is 2 carbons here or here. And either way you'll get the same name. So we just pick one. We've decided to make this our parent chain, and it is an ethane because it is 2 carbons. And we have another 2 carbons over here, so that makes our substituent an ethoxy group. In this example, our parent chain is 1, 2, 3 carbons long. That's where we get propane from. If we number, we have a methoxy group at position 1 and at position 3. So that gives us a 1,3 dimethoxy. It doesn't matter if we number from the left or the right, we'll get the same name. In our last example here, our parent chain is 3 carbons long, 1, 2, 3. Attached to this, we have our methyl group, as well as a methoxy group. Those are both attached at position 2, so that gives us a 2-methoxy, 2-methyl propane. The common name is something you might be familiar with. It's commonly called methyl tert-butyl ether, or MTBE. MTBE is used to prevent engine knocking. In the previous video, we said that the higher the octane number, the more compression a fuel can withstand before detonating. So an anti-knocking agent is a gasoline additive used to increase the fuel's octane rating and reduce engine knocking. MTBE has been used in the US since the 1970s, I believe, to replace tetraethyl lead as an anti-knock additive. This is why when you pump your gas, it says that the gasoline is unleaded. However, due to groundwater contamination concerns, MTBE has since been banned in California, and so now you're seeing other additives used to prevent engine knocking. This is the last video for Interchapter A. If you have any questions about anything we covered, please make sure to ask in lecture.